Intermediate Algebra for Statistics, Polynomial Functions, Part 3. Lesson Objectives. Find the sum functions and difference functions. Use sum and difference functions to describe authentic situations. Lesson Objective. We'll begin with the definition. If f and g are functions and x is the domain of both functions, then we can form the following functions. The sum function, which is denoted f plus g, where f plus g of x is equal to f of x plus g of x. So basically this is saying we take one function, we add another function, and we get a new function called the sum function. The difference function is denoted f minus g, where f minus g of x equals f of x minus g of x. And again, the idea is essentially the same. We take one function, we subtract another function, and we get a new function called the difference function. Example 12. Let f of x equal 5x squared minus x plus 3, and g of x equals negative 2x squared plus 9x minus 7. Number 1. Find an equation of the sum function f plus g. Number 2. Find f plus g of 2. Number 3. Find an equation of the difference function f minus g. And number 4. Find f minus g of 2. So for the first one, f plus g of x is f of x plus g of x. So the blue is f of x, the red is g of x. Next we arrange the terms together. So we have our x squares, we have our x's, and we have our constant terms. Next we combine like terms, and we get 3x squared plus 8x minus 4. So adding these two functions produces a third function. Number 2. Now that we have our third function, f plus g of x, we simply substitute 2 wherever we see an x and we evaluate. Following the order of operations, we have to square first, then multiply, then add and subtract, and we get 24. So f plus g of 2 is 24. Number 3, the difference function. This time we take f of x and we subtract g of x. Now it's very important that we distribute the negative to every single term in g of x. So we're going to distribute the negative 1 to all three terms. We see that this becomes now a positive 2x squared minus 9x plus 7. Arrange terms together, x squared terms, x terms, and constants. Combine like terms and we get 7x squared minus 10x plus 10. Number 4. To find f minus g of 2, we take our new function, 7x squared minus 10x plus 10, and everywhere we see an x, we substitute a 2. Compute the order of operations and we have 18. So when the input is 2 for this function, the output is 18. Lesson objective. Modeling with sum functions and difference functions. Rule. If a difference a minus b is positive, then a is more than b. If a difference a minus b is negative, then a is less than b. And if you think about it, if the difference a minus b equals 0, that means a equals b. So let's use this idea. Example 13. The enrollments in millions at U.S. colleges, WT and MOT, for women and men, respectively, are modeled by the system WT equals 0.15 T plus 5.76 and MOT equals 0.072 T plus 5.43, where T is the number of years since 1980. Number 1. Find an equation for the sum function W plus M Number 2, perform a unit analysis of the expression Wm plus Wt. Number 3, find W plus M of 31. What does it mean in this situation? Number 4, find the equation of the difference function W minus M. And number 5, find W minus M of 31. What does it mean in this situation? Solution? We'll begin with the sum function. So we're going to take W of t plus M of t, combining like terms, and we see the function is 0.222t plus 11.19. Number 2, the unit analysis. W of t, the units are millions of female students. M of t is millions of male students. So our units are millions of students. Number 3, W plus M of 31. We take our function from number 1, we substitute 31 in for t, we multiply and then we add 11.19 and we get 18.072. Now what does this mean in the terms of this problem? It means that the total enrollment for all students, women and men, in 2011, which is 31 years after 1980, will be 18.072 million students, according to this model. Number 4, the difference function. So now we're going to take W of t and subtract M of t. Be sure we distribute the negative to both terms. Combine like terms and we get 0.078t plus 0.33. So this is our new function. Number 5, find the value of this function evaluated at 31. So we take 0.078 times 31 plus 0.33, and we see that this is a positive number. So that means there's going to be more women than men, 2.748. In the terms of this problem, this means that in 2011, women's enrollment will exceed men's enrollment by 2.748 million students, according to the models. So in 2011, there will be more women enrolled than men. Thanks for watching.